Hello and welcome to Mr. Pena Has Flipped. This is video lesson number 9, even and odd functions. So this is concept number 5 of unit 1, and basically we're going to be talking about even functions first. Now an even function is symmetric with respect to the y-axis. That means that when you reflect the function across the y-axis, you're going to get basically the same function. It folds on top of itself. That's what it looks like it does. Okay, so look at this point here, 1.5 and 2.25. Okay, it's on the graph, it's on the parabola. And when I reflect it across the y-axis, that point becomes this point, negative 1.5, 2.25. And so basically what happens is that the y value stays the same, but the x value changes. The sign of it changes. Okay, so an even function that starts out with a point xy on the graph, when you reflect it across the y-axis, it's going to have the point negative xy. Yeah, so it'll always change like that. Here's an odd function. Now an odd function is reflected across the origin. Not, I say not, I tell you, across the x-axis. That is wrong. Reflects across the origin. So once again, it appears to fold at the top of itself, but this time when you fold it across the origin. Okay, so look at the point this time. It's 1.5 and 3.375. When I fold it or reflect it across the origin, that point goes down here, right? And now notice, both of the x and the y have the signs that change. They were positive at the beginning, now they're negative. Okay, so an odd function has a property that if you reflect it across the origin, instead of being xy, when you reflect it, it's going to be negative x, negative y. And you can do this algebraically too. Matter of fact, I prefer it if you did this algebraically. That means working it out. Alright, example 1. Find out if the example f of x is equal to 3x squared plus 4 is an even function or an odd function. Well, first thing you got to do. Now, you're going to do this every time. First thing you do is you're going to plug in negative x everywhere you see x in the original equation. So, everywhere I see an x, I plug in negative x. So it's f of negative x equals 3 so far. Okay, you see all that stuff there. When you simplify it, does it look like the original? Yes. In this case, these two functions look the same. Okay, now I'm talking about this function right here. Looks exactly like this function right here. Now if that happens, if the result looks exactly like the original, it's an even function. That's it. There's no other question about it. Alright. Now, okay, you can read that. You can take notes on this also. By the way, write down the examples. Okay. For example 2, find out if the function f of x is equal to 2x cubed minus 4x is even or odd. Well, I'm going to do the exact same thing. Everywhere I see an x, I'm going to plug in negative x everywhere in the equation. So here it is. I'm plug it all in, simplify it. Okay? Now, you know that if you have like negative x times negative x times negative x, you're going to get negative x cubed. Don't forget stuff like that. If you have an even function, it's going to be positive. If you have an odd function, I'm sorry, if you have an even exponent, it's going to be positive, and if you have an odd exponent, it's going to be negative. Sorry, it's my dog's outside barking, distracting me. I don't know if you can hear. Well, now she's eating. Okay, so here's the original function, and here's the other function when you plug in negative x. Do they look the same? No, they don't look the same, but the thing is, they do have the signs that are backwards. All of the signs are reversed. So what was negative is positive, and what was positive is negative. If this happens, this means you have an odd function. all the signs are reversed. Alright, example 3. Tell if the function is even, odd, or neither. And yes, you can have functions that are neither even nor odd. Alright, so plug in x, negative x for x everywhere you see it. Okay, plug it all in, simplify it. Okay, now does this purple function here, does it look like the original function? Well, no. Does it look like the original function with all the signs reversed? Nope. So this function is neither even nor odd. It's called, you just say it's neither. That's it. Okay. And that's pretty much it. That sound signals the end of our lesson here. Oh my god, we should stop barking there. Okay, so thanks for watching. And please write down all of the notes on this video. And then you're going to write a separate summary. Okay? So thanks for watching, and I'll see you in class.